Okay, in this section we're going to look at how to solve quadratic equations, first by using what's called the square root property and then by completing the square, which they're related methods. So the square root property is this idea that if you have a number squared, and such as x squared, say it equals 25, and you're trying to find all the values of x that make this equation true, trying to solve that, well, that you can actually take the square root of both sides, because you can do anything to an equation as long as you do it to both sides. Okay, so I'm going to take the square root of both entire sides. Now the square root of something squared, the square root and the square essentially cancel. So you get x. But if I just say the square root of 25 is 5, I've actually lost one of the two solutions. Because if you just think about it, there's actually two x's that make this true, both positive 5 and negative 5, because negative 5 squared also equals 25, right? So the idea is, or the thing you need to remember is that anytime you take the square root of a variable squared, you need to put a plus or minus on the other side to account for the fact that a negative number squared will also solve this equation. Okay, so put that in your memory. Anytime you take the square root of a variable, meaning like an x or a letter, right, squared, put a plus or minus on the other side. There's actually a more advanced explanation for this that you might see in college algebra, but that's the main idea. As long as you put a plus or minus on the other side, you'll get all the solutions to an equation, and that's the square root property. So you can use this idea to solve quadratic equations. In order to do that, first you have to isolate the squared part, and then you take the square root of both sides and solve for x. So we'll do this with this example right here. Negative 3x squared plus 12 equals negative 15. It is considered a quadratic equation because the highest power of x is 2. So first I would say let's simplify. Now this one, notice there's not an x term. We have an x squared term and we have two constants. So let's actually combine the two constants by moving the 12 over to the left. That'll give us negative 3x squared equals negative 15 minus 12 is negative 27. Okay, and I can even simplify further by dividing both sides by 3, because negative 27 divided by negative 3 is positive 9. Then we can take the square root of both sides. So we have x equals plus or minus the square root of 9, because the square root and the square cancel. Square root of 9 is 3, so x equals plus or minus 3. Now let's definitely check, because this is the first one we've done. So let's check x equals positive 3. I'm going to plug that into this equation here. So we'll have negative 3 times 3 squared plus 12. Does that equal to negative 15? Let's see, 3 squared is 9. 9 times negative 3 is negative 27. So negative 27 plus 12, 7 minus 2 is 5. Yeah, that is negative 15, so that works. And you can check x equals negative 3 as well. So when I plug in negative 3, we'll have negative 3 times x is negative 3 squared plus 12. Does that equal negative 15? So negative 3 times negative 3 is positive 9. And yeah, we have the same thing. Negative 27 plus 12, yes, is negative 15. So they both do work. Okay, so the idea is get the squared part by itself and then take the square root of both sides and put a plus or minus on the other side and then solve for x. Okay, so on this one's slightly different, but it's more common for what you would see. So there's really two methods for solving this equation. One would be to fully expand and FOIL this part out and get one side equal to 0 and hope it factors, or if not, you could use the quadratic formula. The other way, and actually in this example, it's easier to use the square root property, because the x, there's only one x written on the page, right? It's right there, that's it. and it's inside this thing squared. So let's isolate that squared part by first moving the 17 over. So 3 plus 17 is 20. And we still haven't isolated the squared part because this 5 is in the way. So if we divide both sides by 5, we get 4 equals x plus 3 squared. Okay, now the squared part is by itself. So now we can take the square root of both sides. Square root on the left, square root on the right. So the square root of this thing squared, the square root and the square cancel. So on the right we have x plus 3. And on the left you have to remember to put that plus or minus. And then the square root of 4 is 2. Then to solve for x we just need to subtract 3 from both sides. So we have negative 3 plus or minus 2 equals x. It's a weird way to write it. So first I'm going to flip the left and right sides and say x equals. And then let's break this down into the two parts. Negative 3 plus 2 is negative 1, and negative 3 minus 2 is negative 5. So those are the two solutions to this quadratic equation. Okay, and again, let me show you the other way in case you do get stuck going this way. You could always do it this way as well, is put everything on the right side, and let's make the left side equal to 0. So I'm going to move the 3 over and write it as 5 times x plus 3 squared. Negative 17 minus 3 is negative 20. Then I'm going to FOIL this out. So x, Okay, so x plus 3 all squared. If I write that as x plus 3 times x plus 3 and FOIL, we'll get x squared plus 3x is plus 6x. And 3 times 3 is 9. Say that, and let's distribute the 5. Actually, no, I take that back. Let's not. Let's factor a 5 out of both of these terms rather than distribute and then factor. I can take a 5 out from both the first term with the x squared plus 6x plus 9, and my second term is negative 20. So taking a 5 out of that gives me negative 4. Then I can divide both sides by 5, so that goes away. Just cross it off. So I get 0 equals x squared plus 6x, and then 9 minus 4 is positive 5. Okay, and it looks like that will factor into x plus 1 and x plus 5. And you set each factor equal to 0, and we get the same two answers. Okay, so those are two different ways of doing the same problem. Notice the square root property in this example was easier because the x plus 3 all squared, well, the x is inside a squared term. Okay, so let's do this one using the square root property. Pause the video and try it on your own first. So we have p minus 5 all squared plus 20 equals 4. So I'm going to move the 20 over. So p minus 5 all squared equals negative 16. Now, if you take the square root of both sides, you end up with square root of negative 16. Well, no number squared will equal negative 16. So that would take us into imaginary numbers. We're not going to go there yet. So that means there's actually no real solutions. If we have time at the end of the course, we may learn about imaginary numbers then. Okay, that brings us to completing the square. So if a quadratic equation is, maybe it can't be solved by factoring, and or maybe you don't want to solve it by factoring. Any quadratic equation can be solved by completing the square. Sometimes it's easier and sometimes it's harder depending on the numbers. But the idea is to make it one side into a perfect square just like this. And then you apply the square root property in order to solve for x. Okay, so that's the idea, is what we've been doing is sort of like the part 2 of completing the square. So a perfect square is when you can write something as a number squared. For example, 9 is a perfect square because it's equal to 3 squared. Okay, so that means 9 is a perfect square. We're going to try to write, what we're going to do is write the x part as a perfect square, just like it is here. The p is inside the square. Here, the x is inside the square. And there, the x is inside the square. And there's no other x's. Okay, so that's the idea. There's really two kinds of perfect squares with quadratics. A plus b all squared, if you FOIL that out, you get a plus b times a plus b. So you get a squared plus 2ab plus b squared. or a minus b all squared. It's a minus b times a minus b FOILs into a squared minus 2ab plus b squared. Okay, so for example, like this, x squared plus 10x plus 25. That's called a perfect square trinomial because when you factor it into, you would break the 25 into 5 and 5. X plus 5 times x plus 5, that does work, which you could write as x plus 5 all squared. So this is called a perfect square trinomial. Another example would be x squared minus 12x plus 36. That one's going to factor into x minus 6 times x minus 6, or x minus 6 all squared. So those are two perfect square trinomials. So the idea here is we're going to write one side of each quadratic equation like this. We're going to manipulate it and force one side of it into a perfect square trinomial. Okay, so to do that we have to notice a connection between the first degree term, that means the x term, and the constant. Okay, so how are they related? In this one, 10. How do you get from 10 to 25? Or how do you get from negative 12 to positive 36? And it's always the same. You're going to divide by 2, divide the coefficient of x by 2, and then square that number to get the constant term. So for example, if I take the 10, okay, let's put this over here. 10 divided by 2 is 5, and then 5 squared is 25, and that's how I get 25. Okay, or you could say negative 12. I always include the sign. So negative 12 divided by 2 is negative 6, and then negative 6 squared is positive 36, and we get the constant term. Okay, so what we're going to do is take that coefficient of x divided by 2 and square it to figure out what number needs to go here and here. Okay, so here's some steps to solving quadratic equations by completing the square. I like to put, now there's more than one way to do it, but this way is a simple way. I like to put all the terms with x on one side and move the constant term actually over to the other side just to get it out of the way. And then you'll need to make the coefficient of x squared equal to 1. Notice in all of these, the coefficient of x squared is 1, 1, 1, 1, right in everything we did. By dividing both sides of the equation by whatever the coefficient of x squared is, then we'll take that linear term, divide by 2, square it, and we'll go from there. So let's start on this one. Step 1, isolate the variable terms on one side of the equation, means move the constant to the other side. So step 1, we'll have 3x squared plus 24x equals 60. Okay. Step 2, we've got to divide both sides of the equation by the coefficient of x squared. So that's the 3. And if we divide both whole sides by 3, okay, then on the left, I'm going to split this into two fractions. We have 3x squared over 3 plus 24x over 3 equals 60 over 3 is 20. And you really could just jump straight to this. You don't really have to write this. Okay, so the 3's cancel, and 24 over 3 is equal to 8. So this becomes x squared plus 8x equals 20. Okay. And it really doesn't matter what order you actually do these two steps in. You could reverse them, and either way you'll end up in the same place. Next step, step 3, take half the coefficient of x and square it and add that number to both sides, and that will force this left side to become a perfect square trinomial. So we're going to take the positive 8, this is just off to the side, 8 divided by 2 is 4, and 4 squared is 16. So I'm going to add 16 to both sides. So that'll give me x squared plus 8x plus 16 equals 20 plus 16. Okay. if you do it correctly, every time the left side, or one side, whichever side has the variables, will factor into a perfect square. So let's see, 16 breaks down into 4 and 4. So if I do x plus 4 times x plus 4, which I can just write as x plus 4 all squared, I do get a middle term of 8x, so that's good, equals 36 on the right side. Okay, now we're at a point where it looks like the equations we were solving previously. So we can do, that was step 4 right there, factoring. Oops. Step 4, we factored it into a perfect square. Step 5, solve using the square root property. So now I can take the square root of both sides. So I'm going to copy what I've got, x plus 4 all squared equals 36. And then take the square root of both sides. Let's make some more room here. Okay, and then square root of x plus 4 all squared. Square root and the square cancel. So now I'm solving for x. So I get x plus 4 equals, now I have a variable squared, so I've got to put a plus or minus on the other side. And the square root of 36, luckily that's a nice whole number, is 6. So we get x equals, let's see, move the 4 over, negative 4 plus or minus 6. So if we do negative 4 plus 6, negative 4 plus 6 is 2, and negative 4 minus 6 is negative 10. So let's write that nicely in order. So negative 10 and 2 are the two solutions to this quadratic equation. Okay, and that's how you do it, by completing the square. Okay, so let's do another example like that. I recommend that you actually try this one on your own first and then watch if you get stuck or if you need to check your answer. So refer to these steps. You need to memorize these steps. Okay, so we're going to isolate the variable terms and then make the coefficient of x squared equal to 1. And actually, that's kind of nice because the coefficient of x squared is already 1. So all we have to do is move the 11 over. So that'll give us x squared minus 12x equals negative 11. Now off to the side, I'll do the calculations here. Negative 12 divided by 2 is negative 6. That number is going to come back. I'm going to show you a trick in a minute. So I'm going to circle that. Okay. Then negative 6, if I square that, I get positive 36. So that's the number I'm going to add to both sides. So let's come over here. We have x squared minus, x squared minus 12x. Let's add 36 equals negative 11 plus 36. Okay, now next we want to factor the left side. And the reason I circled this is because this left side will always factor into x plus this number. So minus 6 all squared. Okay, so those two numbers, whatever you get when you divide by 2, is always going to go right here. Okay, you can FOIL it out, it does work. And then let's simplify this side. 36 minus 11 is 25. Nice, now I can take the square root of both sides. So on the left we have x minus 6. On the right we have plus or minus 5. So x equals positive 6 plus or minus 5. See, 6 minus 5 is 1, and 6 plus 5 is 11. So x equals 1 and 11 are the two values of x that solve that equation. Okay, so good on that one. Now pause the video, try the next one. Okay, now the constant term in this one is already on the other side, so might as well just leave it there and go ahead and divide both sides by the coefficient of m, which is 2. And I'm just going to go ahead and split it into multiple fractions and divide each term by 2. So m squared, see 16 over 2 is 8 minus 8m equals 2. So now we take this coefficient of m, which is negative 8, divided by 2 to get negative 4. Circle that. Then we square it. Negative 4 squared is 16. So let's add that to both sides. So we have m squared minus 8m plus 16 equals 2 plus 16. So on the left, it's going to factor into m plus this number, minus 4, all squared equals 18. And we take the square root of both sides. Now square root of 18 is not a well, 18 is not a perfect square, so the square root of 18 is not a whole number. So we'll come back to that in a minute. Square root of m minus 4 squared, we have m minus 4 equals plus or minus the square root of 18. So m equals 4 plus or minus the square root of 18. Okay, we need to simplify the square root of 18, or at least attempt to simplify it. So I usually start with 18 and divide by small prime numbers, such as 2, 3, 5, 7, 11, so on. So 18 divided by 2 is 9. 9 divided by 3 is 3. Now if there's 2 of any number, we can pull that out front. So that means square root of 18 is equal to 3 times the square root of 2. Because this 3 came out front, and this 2 stays under the radical. Okay, so we have m equals 4 plus or minus 3 radical 2 are the two solutions that solve this quadratic equation. So they're decimals. You know, you would have to type 4 plus 3 times square root of 2 into your calculator to estimate them. And actually, let's go ahead and do that on this example. So if I do 4 plus the square root of, 4 plus 3 times the square root of 2, I get, let's go to 3 decimals, 8.243 if I round up. Or if I do 4 minus 3 times the square root of 2, that's negative 0.243. Those are two approximations of the numbers of these two exact solutions. So these are considered exact answers, and those are considered approximate answers. It just depends on the problem and what you're finding and what you're asked for as to which one you want to give. Okay, so pause the video and try the next one on your own. 4a squared plus 50 equals 20a. Well, let's see. I need to rearrange here. I've got an a squared term and an a term, but I need to get those on the same side, and I need to get the constant term on the other side. So 4a squared minus 20a equals negative 50. Okay. We have to divide by this coefficient no matter what. So I've got to divide everything by 4. So that gives me a squared minus 5a equals, well, 50 doesn't divide evenly by 4, but I can take a 2 out and write it as negative 25 over 2. Okay, so now we take this coefficient of a, which is negative 5, divided by 2, which is just negative 5 halves. It doesn't simplify. And then I'm going to square it. Negative 5 halves squared. Negative 5 squared is 25, and 4 squared is 4. So when I divide the coefficient by 2, I get negative 5 halves. That's the number that I'll factor it into after I add 25 fourths to both sides. Okay, so on the left we have a plus this number, so minus 5 halves, all squared. And then on the right, I need to simplify. I probably shouldn't have reduced this fraction, negative 50 over 4 to negative 25 over 4, because now I need to write it as a fraction over 4. So let's go back to 50 over 4. And then that's plus this 25 over 4. Okay, on the left, I'm just going to copy while I simplify the right side. So negative 50 over 4 plus 25 over 4 is negative 25 over 4. It's negative. Something squared will never equal a negative number. So we can stop right there and say there are no real solutions. Okay, that's it for completing the square. So next we'll look at the quadratic formula.